Okay, so this is 1.2a. Okay, so up at the top of this page, you can see that I have a graph. This is the function 1 over x. It has two separate asymptotes. It has a vertical asymptote at x equals 0, and it has a horizontal asymptote at y equals 0. All right, and so I would like to talk about what the limit is. In fact, let me write this down. The limit as x approaches infinity of this function. Okay, now this is positive infinity, so I'm trying to figure out what's happening as I go this way, to the right. All right, and because there's a horizontal asymptote, right, you've seen this function before, you know that this function is getting smaller and smaller and smaller and smaller, but it's never going to quite get to 0. But that's the thing. Limits are about what the function is approaching, which means this is approaching 0. Okay, and again, it's because of the horizontal asymptote. Okay, and then likewise, if I do it the other direction, the limit as x approaches negative infinity, that means I'm going this way. Okay, and I'll write that. I just screwed that up. Let me see if I can fix that. 1 over x, there we go. It's also approaching 0. All right, and both of those are because it has a horizontal asymptote. Okay, so in the rounded rectangle, you can see the definition. The line, y equals b, is a horizontal asymptote of the graph if either the limit as you're approaching the right is that number, or the limit approaching infinity from the left is that number. So for example 1, it says graph each function to find the horizontal asymptote. So I'm going to let you guys go on to Desmos and graph this, but it looks something like this. It does have a horizontal asymptote. You have to zoom way, way out to see it, but it is 0, which means the limit as x approaches infinity of that particular function equals 0. Likewise, as you are approaching negative infinity of the function, that also equals 0. Okay, for this one, when you graph it, it ends up looking something like this. Okay, and it has two separate horizontal asymptotes, and it may take a little bit of zooming out for you to see it. There's one up here at 3, and there's another down here at -3, which means that the limit as you are approaching positive infinity of this function will equal 3. But if you're going towards negative infinity, it equals -3. Okay, now for this last example down here, number 2, I'm going to use some of the, yeah, I'm still at school and the bell just rang. Anyway, I'm going to use some of the limit laws from a lesson or two ago. Okay, so first thing, I'm going to break this, what's called the argument, apart. Okay, so the limit as x approaches infinity of 5x over x plus the limit as x approaches infinity of sine of x over x. Now, I want to make sure that I take a moment to say that this is not this. Okay, I asked you to memorize this one already. That one equals 1, but that's not what this one is. Do you see that? This is approaching infinity, not 0. Okay, so this may require you to break out some sort of a graphing utility. On the first limit right here, the x's cancel out, and the limit of a constant is the constant. This one has a horizontal asymptote. you've got to look way, way, way far to the right, and you will see that that function is approaching 0, and this limit equals 5.